Okay, here's another one. A racing car is one of many toys manufactured by this company. There's a mean of 55 minutes and a standard deviation of 4 minutes. The company closes at 5. If one worker starts to assemble a racing car at 4, what is the probability that she will finish this job? Okay, so I'll just show you the answer and you can read it. And here's the picture. And another example here. So I'll just give you some answers here. And let's move on. So now, instead of, if we know the z-value, finding the area, we're going to reverse it. If we know the area, find the z-value. So how do you do that? You just look up the area in the table, and then you can find the corresponding z-value. So find a point z such that the area under the standard normal curve to the left of z is this. So you just go to the table and you look for this number. So the number is 9251. So we want to find the z that has 9251 to the left. So we look at the table and we look for somewhere in the table 0.9251. We see that it's here. That means the z-value is 1.44. So that's the answer. They don't tell us, they don't write the answer out, but that's the answer. Okay, here's another. Find the z-value such that the area under the standard normal curve in the right tail is 0.005. So again, you look for a point. Oh, but this is in the right tail. So the area to the left of, we want in the left tail to be this, right? If it's this much in the right, then to the left it's 1 minus that. So it's this. So look for that in the table. They say that table 7 doesn't contain that number. So find the value closest to this number, which is either this one or this one. Do they show us the table? No. No, but you can look at the table yourself. And then, so it's either this or this. If we choose this one, z will be that. If we choose this one, z will be this. So usually what they'll say is split the difference and say it's 2.575. Okay, so that would be 2.575, or you could choose one of these numbers. Okay, and again, same kind of thing, so that the area in the left tail is 0.05. So the value closest to 0.05 is either this one or this one. If we choose this one, it'll be, z is minus 1.65. You can check this in the table. Okay, so the next one is you find the z-value and then the corresponding x value. So let's see what that means. So recall in example 614, it's known that the life of a calculator manufactured by this company has a normal distribution of 54 months, with a mean of 54 months and a standard deviation of 8 months. What should the warranty period be to replace a malfunctioning calculator if the company does not want to replace more than 1% of the calculators? So let's see, we want, so here's a picture of it. The mean is, lifetime is 54. So if we set our warranty like up here at maybe 60, then most of the calculators wouldn't last that long. Most of them only last 54. So if we set it at 60, most of them wouldn't last that long, and we'd have to replace a whole lot of them. So what we want to do is set that warranty down here at something lower than 54, such that only 1% of them will have to be replaced, so that only the area here should only be 1%. So how do we do that? How do we find the number x so that only 1% of the area will be to the left of x? So we want the area to the left of x to be 1%. So we want to find the z value from the normal distribution table for 1%. And then they say the table doesn't contain 1%, so the closest value in the table is this one, which is pretty close to 1%. And the z value for that is this. So now we know the z value. So going back to this, we know the z value. We know that the z value should be here, so we just need to figure out what's the corresponding x value. How do you figure that out? This means the number of standard deviations below 54, or below 0. So it's minus 233 standard deviations, and we have to remember what the standard deviation size was, and it was given somewhere. It was given us 8, so we want minus 233 times 8 months. So we get 54 minus 233 times 8 months. So we want to drop it down to minus 18 months, and so that's about 35.36. So that's what this number should be. That's what our warranty should be. We say we guarantee our calculators will last for 35.36 months, and then most of them are going to last longer than that. 1% will last less than that. So we've arranged it so that we only have to replace approximately 1% of the calculators. Okay, now I'll just scroll through some more examples, and you can stop and read them. Okay, and now this is a new topic, so I'll start a new video.